Here's a short video on how to calculate something called the Spearmans rank correlation coefficient. Now, a correlation coefficient is simply a number between -1 and 1. It gives you an idea of how well correlated two variables are. So if you were to think about a scatter graph, we know what a good correlation looks like. It's going to have lots of points that are going up in something that we can recognise as a kind of linear trend. As one variable increases, so does the other. So this would have a correlation coefficient value of, well, it'd be positive because it's a positive correlation. And it's pretty good, so it's going to be close to 1. 1 would be a perfect correlation with everything on the line. But looking at this is not going to be far away. So we would say that our correlation coefficient is going to be, I don't know, somewhere in the region of 0.7-ish. This R is the symbol we use for a correlation coefficient, and because we're going to be calculating Spearman's rank correlation coefficient, we have to put a little s down there. If I had a negative correlation, something like this one's not quite so good, but there we go, let's do it like that. This one is going to be negative, and it's not quite so strong, so let's put a lower number. Now, if you had something with absolutely no correlation whatsoever, well, there you're expecting your value to be 0. So it's a good measure of how well correlated two variables are. And we're going to use this to interpret some of the results you collected on your fieldwork. So, when you went off to Wittering and collected lots of numbers of species on various quadrats and did that transect and took lots of measurements about soil temperature and those kind of things, you'll have filled in a table that looks a little bit like that. Okay, so this is your results table here. And now I've got my blank at the moment, but I've got some data I'm going to put in it. Now we told you had a choice of the abiotic factor you could measure. So let's imagine, for the sake of this demo, that I chose to measure the soil temperature. Okay? And I was looking at the number of species found in each region as we went along the transect and as that soil temperature changed. So let me just put in some data here. These are fairly typical results. Okay, so you can see how the soil temperature is changing in there. We've got some, they're all around the 20 mark, but some higher than others. Now, at each of those stations, you will have had a look and recorded the number of species that were present. So this is a fairly typical set of data. I just realised I've missed one of my data points out. This is number 19.5. Okay. And that is 20.2. So, what Spearman's rank correlation does is it looks at the way this data is scattered in a very simple way. All it says is, well, if we were to plot this, we'd probably get a graph. There might be some kind of correlation there. So let's plot something with a weak correlation here. Okay. And what Spearman's rank correlation does is it assigns them ranks according to where they come in the sequence. So this variable here on our x-axis, this would be number 1 because it has the lowest value of x. This would be number 2, number 3, number 4, 5, 6, and 7. You could do the same up the y-axis here. This would be number 1 because it's the lowest along the y-axis. This would be number 2. This would be number 3, 4, 5, 6, and 7. Now what you can see here is that actually sometimes the x and y rank agree with each other, 1 and 1, but sometimes they don't. That's number 3, that's number 2. What the Spearman's rank correlation is doing is it's comparing how often do these agree and how often are they different. And this is how it works. You need to take your data and you need to place them in rank order. So I'm going to go from lowest to highest. So what I'm going to do is I'm going to try and find the lowest values here. Now these three are all 19.5. So they'd all be ranked 1, 2 or 3, but I've got 3 of them. So what we actually do is like we share out their position. So I say, well, 1, 2 and 3 are the ranks that are available. Well, let's give them the average. So we add up 1, 2 and 3, 6. We divide it by 3 because there's 3 options here, and they all get rank number 2. The next one, next highest one, is going to be this one here, my 20.1. And if you think about it, places 1, 2 and 3 have been taken, so that's got to be ranked 4. Then this is going to be ranked 5 here, that's going to be 6, 7, and then that's the largest, so that's ranked 8. We're going to do exactly the same over here for our number of species. So if you have a look, there is, well, this is our lowest one by some way, so that's going to be rank number 1. And then if you look, I've got 3 there, so that's quite low. So if you put a 2 in that, and then I've got 4 there and there. So ranks 1 and 2 are taken. These two here are going to be sharing ranks 3 and 4, and that means they have to have the same score. Ranks 3 and 4, well, they add up to 7. So each of these is getting half of that. They're getting the average rank, effectively. They're getting 3.5. So then those 3 and 4 are gone. That means the next rank I'm putting in place is going to be 5. So that was number 4. So that's going to be this one down here. This is our next biggest number. And then if you look, I've got the same problem again. I've got 2 6s. So that was rank 5. The next 2 ranks are 6 and 7. And I've got 2 of them to share out, so they're going to get 6.5 each. So that's 6, 7, and that means that rank 8. Okay, we've assigned ranks to our 2 variables. Let's see how often they agree and disagree. And we're going to work out something D, the difference between the 2. So that's really easy. You do this number minus this number. So 8 minus 6.5, that's 1.5. This one's going to be 7 minus 8, that's minus 1. 6 minus 3.5. 2.5, that's going to be 2, 1, minus 1.5, minus 3, and then minus 1.5. Now this is a measure of how much agreement there is, but it's not that useful on its own, because I've got some negative numbers, I've got some positive numbers. If I just added all of this up, it might well come to 0, but actually there's quite a lot of disagreement. So what can I do to sort of measure the scale of that disagreement? Well, it's simple. You square all of these numbers. And that will make even the negative ones positive, so that you can add that up and get an idea of the scale of disagreement. So 2.25 is 1 and 1.5 squared. Minus 1 squared is 1. 2.5 squared comes out 6.25. 2 squared is 4. 1 squared is 1. Minus 1.5 is 2.25. Notice, even though that's negative, it comes out as a positive. Minus 3 squared is 9. And minus 1.5 squared is 2.25. I'm now in a position to add all of those up, and that's where I use this little sigma symbol, that means the sum of. And by adding it all up, I get a figure that represents the kind of scale of difference between the ranks. Okay, that on its own is not very helpful. What we're going to do is we're going to use this equation here to turn it into our R value. Okay, so this is the equation for Spearman's rank correlation. And you do it as follows. So I am going to calculate my R value by doing 1 minus 6 times the sum of the D squares. Well, that was 28. And I'm going to divide that by n cubed minus n. Now, n is the number of pairs of data you've got, which in this case is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is going to be 8 cubed minus 8. Time to get a calculator. Do a bit of tinkering there. I've cheated and done it in advance. So it's going to be equal to 1 minus 168 divided by 504. Okay, I've worked that out on my calculator. Then take it away from 1. And the answer you get is 1 minus 0.3. Scratch that. 1 minus 0.333 goes on, I'm going to leave it at 3 decimal places, and therefore my answer for R is going to be 0.666. I'm going to round that up, let's have it as 0.67. Okay, this is my R value. Put a little S there to show it's the Spearman's rank correlation, and that value there tells me how correlated are these two things. So it's positive. As one increases, so does the other. So that's suggesting as my soil gets warmer, I will be finding more species. Seems to pan out in the data as we look at it.
And it's quite a high number, so 0.67 is not up at 1, but it's a pretty good correlation. So far we've learned something. There is a correlation, and it's looking quite strong.